Hello, this video presentation is about completing the square part 2. Part 2, coefficient of the quadratic term not equal to 1. So, actually not equal to 1. So, if we look at 3x squared plus 12x minus 50 equals 4. Our leading coefficient here is not 1. It's not a perfect square. Remember, completing the square, we're going to have something that looks like this. This has to be a perfect square. The way we make it a perfect square, very simple. Make leading coefficient equal to 1. Exact same thing we did yesterday, but we just have one extra step. Also, we have to move this 50. We have to get it in the proper form. 3x squared plus 12x equals 54. We want this to be a 1 here. So we divide by 3. We divide everything by 3. And we get x squared plus 4x plus something equals 18 plus something. Then the rest of this is like yesterday. We take half of this number, divided by 2, square it, and we add it to both sides. So now I have x squared plus 4x plus 4 equals 22. Really didn't need the parenthesis there. We factor x plus 2, quantity squared, equals 22. And then we take the square root of both sides. Always remembering the plus or minus. So now we have x plus 2 equals plus or minus radical 22. Subtract 2, x is equal to negative 2 plus or minus the square root of 22. All right, let's do one more. Actually, we might do two more. The next one is 2x squared plus 4x equals 1. We want this coefficient to be a 1, so we divide by 2, divide by 2, divide by 2. Uh-oh, a fraction. And we get x squared plus 2x plus something equals 1/2 plus something. We take half of this and square it. 1 squared is 1 plus 1 plus 1. We factor this. X plus 1 squared equals 1/2 plus 1 is really 2 over 2. We need a common denominator. So we have x plus 1 quantity squared equals 3/2. And then we take the square root. Square root plus minus square root. And we get x plus 1 equals plus or minus the square root of 3 over the square root of 2. Now, what we did yesterday, we have to rationalize the denominator. By the way, that's the square root of 2. Go back up here. Both of these are inside the radical, so they're each in a square root. And now we multiply by the square root of 2 over the square root of 2. X plus 1 equals plus or minus the square root of 6 over 2. And we're almost done. Subtract 1, subtract 1. X equals negative 1 plus or minus the square root of 6 over 2. But, sad to say, we have to add these together. Do not leave the answer like this. Although mathematically correct, it is not in the proper form. We have to get a common denominator, which is 2, and x is equal to negative 2 plus or minus radical 6 all over 2, and we're done. All right? Pretty straightforward. This is important. All right? Don't forget this. You'll lose points for nothing. And the only other thing that's new, make the leading coefficient equal to 1. All right, that's it. I guess 2 examples is all we get. Have a great day, and I'll talk to you tomorrow.